In lesson 1 of this new chapter, this unit or chapter is actually going to include 21 different lessons, and it is written by a person from Harvard, and it really helps people understand how to use ratios, percents, any kind of proportion problem solving. So this is going to be a little different than our book method and our videos, but basically I'm going to be making my own videos for this chapter. So in lesson 1 in the workbook, you can just follow along. The first page is all the definitions. We're going to leave that till the last page, and we'll go back and review all the words at the end of the lesson. So if you go to the second page in the workbook, the first part is just a review. We need to make sure we understand what equivalent fractions are. So in question 1, it says circle the equivalent fractions. And it tells you there are 3 equivalent fractions in each set. Well, there's a lot of ways we can compare fractions. One is we can multiply diagonally, but since there's 4 fractions, that could really be a hassle having to multiply each set diagonally. So what I'm going to do instead is I'm going to reduce every fraction. So this fraction is 1/2, and that's already reduced, so I can't do anything about that. 5/10. I could divide the top and the bottom by 5. So 5 goes into 5 one time and into 10 twice. So I can see that these two right here are the same. And then if I look, I know there's got to be 3 equal ones, so I look at the other 2 and figure out which one is exactly equal to half. And you can either do that by reducing them down to half, or you can just look at the numbers. 7 out of 15, 7 is not half of 15, but 6 is half of 12. So if you reduce 6/12, that would also reduce down to half. So we found the 3 fractions that are equal to each other. Okay, and the next one, 3/9 is not reduced. So if on the top and the bottom, I could divide by 3. So 3 goes into 3 once, and 3 goes into 9 3 times. I see another fraction that is a 1/3. So basically I know that the 3 fractions are going to be equal to 1/3. That one, and then I just have to see which of the following 2 are 1/3. If you reduce 2/8, they're both even, so you could divide by 2. That top number would be a 1, and the 8 would be a 4, so that's not equal. But this one, 6 out of 18, if I divide it by 6, 6 goes into 6 once and into 18 3 times. So therefore, I found all the fractions that equal a third. Number 2, we have to just say if they're equivalent or not. So we could do that by many methods. We could reduce them both down if we wanted to. We could multiply diagonally, and if we get the same answer. There's another third way that a lot of people don't realize. If you just look at the top and the bottom number, 3 to 12, you're multiplying the top by 4. If you're multiplying the bottom by the same amount, it's 5 times 4 is 20, that means yes, it's equal. Again, we could have done that same answer by multiplying across. That gets to be 60, and 5 times 12 is 60. So we can do it that way also. On this one, the looking across, saying 25 times what is 30 doesn't work very well in this method because I don't know 25 times what is 30. So that's not going to work well. I certainly don't want to multiply across because I don't want to take 45 times 25. That's going to require a lot of paper, and there's got to be an easier way than that. Although the 40 times 30 would be very easy to do. So my way that I think would be the best in this situation would be to reduce the top and bottom by 5. So I'm going to divide the top by 5. So 5 goes into 25 5 times, and 5 goes into 48. I'm going to do the same thing over here. I can divide by 5. 5 goes into 36 times, and 5 goes into 45 9 times. This 5/8 is reduced, but 6/9 I could still divide by 3 on that. So 3 goes into 6 twice, 3 goes into 9 3 times. These two are both in reduced form, and they're not the same number, so no, it's not equivalent. All right, so now number 3, we're just finding the missing top or bottom number. Very simple to do that. Just figure out what's going on the top. So on the top, I'm getting 3 times as big, so I need to get 3 times as big on the bottom, which makes that a 6. The bottom here, I'm getting 3 times as big, so the top needs to get 3 times as big, which makes it a 3. This one's a little bit harder. It's a lot harder because I don't know what's going on the bottom. I don't know how many times bigger it's getting. There's a couple things I could do, but right now what you could do is you could reduce the 5 out of 25. If I divide by 5, 5 goes into 5 once, and 5 goes into 25 5 times. And now I can see here I'm getting 4 times bigger on the top, so I need to get 4 times bigger on the bottom, which gives me a 20. All right, number 4, I have to basically simplify each fraction. So if I divide this one, I could divide the top and bottom by 3. So 3 goes into 12 4 times, and 3 goes into 15 5 times. On this one, I could divide both the top and bottom by 2 if I wanted to, because they're both even. Otherwise, I do know I could divide by 22. That'd be the fastest. That's called the greatest common factor. 22 goes into 22 once. 22 goes into 44 twice. So I'm done already. This one, they're both even, so I can divide by 2. 6 divided by 2, or half of 6 is 3. And then half of 14 would be a 7. Okay, on this one, I have to divide by 5. 5 goes into 10 twice, and 5 goes into 35 7 times. And then the last one, I could divide by 3. I know that right away, but I could also divide by 9. And if I can think of a bigger number, I use it because it's faster. 9 goes into 9 once, and 9 goes into 27 3 times. And the last review question, it says a class is having a pizza party, and they ordered 2 pizzas from different restaurants. The class ate 5/6 of the pizza from Dorf's Pizzeria and 9/12 of the pizza from Perfect Pizza. Did they eat the same amount from each restaurant, and explain? So on this one, I basically need to say, are these 2 fractions equivalent? There's a couple things I could do. I could make the denominators both the same, so I could change the bottom numbers to 12 if I wanted to. I could compare multiplying across. I could reduce both fractions. 5/6 is already reduced, but I could reduce 9/12. So if you reduce 9/12, you could divide by 3. 3 goes into 9 3 times, and 3 goes into 12 4. Since these are both reduced form, do you see how they don't match? So the answer would be no. We did not get the same amount of pizza. Okay, on this page it says there are 2 trees in this picture. One is 6 feet tall and the other is 2 feet tall. There are many ways to compare the heights of these 2 trees. How would you compare these 2 quantities? There are a ton of acceptable answers for this. Many kids will just look at it and say, well, one is 6 feet and one is 2 feet. So they say that the 6-foot tall tree is taller than the 2-foot tree. That would be comparing. That's acceptable. One might do a subtraction, and they might say this 6-foot tree right here is actually 4 feet bigger than the 2-foot tree. They do that by subtraction. Okay. With this whole chapter, we're not going to be comparing numbers that way. We're not going to look at a subtraction relationship or one is bigger than the other. What we want to focus on is a multiplicative relationship. Did you hear the word multiply in that? So basically we're going to be looking at how many times bigger or how many times smaller. That's what we're going to be looking for in this whole chapter. So if you look at this, do you agree that the 6-foot is 3 times as big as the 2-foot? Because doesn't it take 2 times 3 to make 6? So you could just put 6-foot is 2 times as big as, sorry, I have that switched around, sorry. No, I have that right. 6-foot is, that's a mistake. 6-foot is 3 times as big as the 2-foot. Okay, so the 6-foot tree is 3 times as big as the 2-foot tree. Very good. Okay, on this next page, they're talking about a different comparison. They have a teacher's desk, which they are representing, measuring it being 4 paper clips long, and a student's desk being 1 paperclip long. Question 1 says, represent the relationship between the lengths of the 2 desks as a ratio. That's a new word, so that's a word we have to know very, very well. A ratio is a comparison that expresses a multiplicative relationship between the 2 quantities or measures, meaning how many times bigger is one or how many times smaller is one would be what we're looking for here. So if you look, the teacher's desk is definitely longer. So we can see the teacher desk is 4 and the student desk is only 1. So we need to write it as a ratio. There's actually 3 ways to write a ratio. If I want to compare teacher's desk to student, I'm going to put teacher's desk being first. So one way we could do is the word 2. So you could write 4, because the teacher's desk is 4, 2, the word 2, sorry, and then 1. That's one way to write it. We're not going to barely ever use that kind of form in our ratios with the words. Instead, you'll see this often in math. It'll say 4:1. That means 4 to 1. It's a 4 to 1 ratio. Typically, you can write it like that. However, most of the math problems, when you get to farther and farther lessons, we're always going to write it as a fraction. So I'm going to write 4 fraction line 1. And this fraction line is read as the word 2. So we'd say 4 to 1. And in ratios, it is okay if it's improper. We are not going to be switching that over, changing it if the number is bigger on top. Okay? So the value of the ratio is really just doing a simple calculation. When it asks the ratio, we wrote it 4 to 1. But the value would be actually calculating that out. So it's taking the top number divided by the bottom number, but they're going to change this wording. Instead of top and bottom, they're going to call it front term and back term. The front term is very easy to pick out which the front term would be there. Front term would be the one in front. So the 4 is the front term and the 1 is the back term. That was really obvious if you write it like that. It's not as obvious if you write it up and down. So you just need to know that the front term would be the top number, the bottom term would be the bottom, and when they ask you the value of it, basically you're just going to take the top divided by the bottom. So 4 divided by 1 is 4. So basically you're saying one desk is 4 times as big, the teacher's desk is 4 times as big as the student desk. That's how you find the value, is just by a simple division question. And then it says label, question 3, label the front term or the compared quantity to the back term or base. So remember how I said we're going to compare the teacher's desk to the student's desk? So the front term, we call it the compared number. We're comparing the teacher's desk. That's why the front term is 4. So the front term is 4. The back term is what you're comparing it to. We're comparing it to the student's desk. The student's desk was 1. So there's going to be a lot of names for the same thing in this chapter. You have to know that the front and back would be the top and the bottom number. You have to know that the front term in comparing is exactly the same as the back term and base quantity. And finally, describe the relationship between the 2 quantities in words. I would probably just say teacher's desk, because that's what we're comparing. So I'm going to have a hard time writing this. Teacher's desk is 4 times as large as students. Sorry about my writing. I'm using my finger. All right, that should be good. Okay, on example 3, it says Lisa and her brother Tim went to the store today and bought some brownies. Lisa bought 8 brownies and Tim bought 2. For all the solutions, represent the ratio relationship using a diagram. So they want us to kind of draw a picture. It says, what's the ratio of the number of Lisa's brownies to the number of Tim's brownies? So if I wanted to draw a picture and it's telling me to compare Lisa to Tim, So that order is really important. The fact that I see Lisa first means I've got to look at Lisa's amount first. So Lisa has 8 brownies. So I'm just going to draw that. There's 1, 2, 3, 4, 5, 6, 7, and 8. So she has 8 brownies, and I want to compare that to Tim. So remember when we did our numbers, we did our fraction line. That's like our word 2, comparing that to, and then Tim is only 2. So I'm going to put 2 brownies for Tim on the bottom. So this is the ratio of Lisa's to Tim. So if I wrote that in numbers instead of just a diagram, I would have 8 here, fraction line 2. Number 2 says, the number of brownies Lisa bought is how many times the number of brownies Tim bought. Well, that's really finding out the ratio value. You're asked, what does this equal? And you should be able to see here, first of all, we could reduce it if we wanted to. So if I looked at this one, 8 and 2 are both even, so we can divide by 2. So 2 goes into 8 4 times, and 2 goes into 2 1 time. So we have a 4-to-1 ratio again. But if it still says how many times bigger, I've got to do the value. And remember how that's just a simple division question? 4 divided by 1 is 4, or 8 divided by 2 is still 4. So Lisa brought 4 many times more brownies than Tim. Number 3, what's the ratio of brownies, Tim's brownies, to Lisa? Now they're asking a different thing to compare. They want us to look at Tim's first, so therefore I'm going to draw my diagram. So Tim has 2, that's going to be the top, and then my fraction line. And now compare that to Lisa's. Lisa's is the bottom, and there's 8, so I have to draw 8. Okay. And that looks like a completely different problem, doesn't it? If you look at the diagrams, this is more on top than on question 1. You have more brownies on top than the bottom, but this one we have less brownies on top. So it's going to be a different value, isn't it? So if I look and I want to use numbers instead of pictures, I have 2 brownies on the top, and I have 8 brownies on the bottom. And if I compared that or reduced that, I could divide by 2. 2 goes into 2 once and into 8 4 times. So the number of brownies Tim bought is how many times the number of brownies Lisa bought. Well, that's a division question. Well, 1 divided by 4, you could change it to a decimal if you wanted to, but that's basically a reduced fraction. So we could just keep it as 1/4. So Tim bought 1/4 as many brownies as Lisa. Now up here, we got it to one number because we could do that, right? 4 divided by 1 was 4. But this one, 1 divided by 4, is, if you did that on a calculator, is 0.25. And you could say it's 0.25 as many times, but more than likely we can just keep it in fraction form and say it's 1/4 as many as Lisa bought. So it really matters what number you talk about first. So be careful in what you're comparing and what your base value is. On question number 4, it says Ryan, a basketball player, is 6 feet tall. And his friend Steve, who is shorter than Ryan, is 60 inches tall. Ryan says the ratio between his height and Steve's height is 6 to 60. Is 6 to 60 the best way to describe the relationship between Ryan's and Steve's height? Well, if we just look and see, make sure the order is right, it says he's comparing his height to Steve's height. So his height does need to be first, and you can see that his height is 6. Compare that to Steve's, and Steve's height is 60. So that's where he's coming up with his 6 to 60. But if I reduce that fraction, so I'm going to reduce that down, so I'm going to divide by 6. 6 goes into 6 once and into 6d 10 times, okay? And I looked at the value of that amount. It's looking like, because 1 divided by 10, I'm not going to change it to a decimal, it's just 1/10. You're saying that Ryan's height is 1/10 the size of Steve. Do you really think Steve is 10 times taller than Ryan? So you take 10 Ryans, and you'll make a Steve? Probably not. And the reason that doesn't work out well in this situation is because of our labels. See how that's 60 feet, and this is, 6 feet, and this is 60 inches. When we compare numbers, we should make them the same label or measurement. So I can easily change the label, and so basically, if I took 12 times 6, if I took 12 times 6, because there's 12 inches in a foot, so 12 times 6 is 72. So now I have them both in inches. So now when we compare, Ryan, his height is 72, compared to Steve's, which is 60. Okay, if I reduce that down, I could divide by 12. 12 goes into 72 6 times and into 65 times. So there is 6 to 5, meaning Ryan is a little taller, but only by a ratio of 6/5. Okay, so if Steve is 5 units tall, Ryan would be 6 of those units tall. Is how that you can read that. Okay, and the last example is in a survey of 50 7th graders, 10 chose Orangina as their favorite drink, and 40 chose Sprite as their favorite drink. Find the following ratios and the value of each ratio, and then say what the ratio means using words and numbers. Okay, so number 1, it says the number of 7th graders who chose Sprite to the number of 7th graders who chose Orangina. So do you see how they are talking? They want you to compare the people who are Sprite first. So therefore, I'm going to start with the Sprite. Sprite is there's 40 kids that like Sprite. And then it says compare that to. 2 is a big key word there. So every time I see a 2, I know that's my fraction line. And 7th graders that choose Orangina is 10. So there's my ratio. It says find the following ratios and the value, meaning what does that equal? Well, if you just solve that, 40 divided by 10, the value is, so this is the ratio right here, if I would reduce it, do you see how you can divide by 10? So it'd be 4 to 1, so that's the ratio, that's doing the first thing. The value is just dividing that. 4 divided by 1 is 4. And then what does that mean? Sprite is 4 times more than orange. I'm just going to use an O for abbreviation. Okay. Number 2. It says the number of 7th graders who chose Sprite to the total number of 7th graders. So if I start with what they say, so they say look at the Sprite, we can do that, that's 40. Compare that to see the word to, that's my fraction line. Total number of 7th graders, that's not 10. 10 is how many chose orange. 50 is how many total there are. So if I reduce that ratio, I could divide by 10. 10 goes into 44 times and into 55 times. So there's my ratio. This is the Sprite to total students. So the value is 4/5 because you could leave it as 4/5, 4 divided by 5, which is going to give you a decimal. So we might as well just say 4/5 is your value. And what that means is 4/5 of the students, 4/5 of the students like Sprite. Okay. And number 3, the number of 7th graders who chose Orangina to the number of 7th graders who chose Sprite. So now they're just switching the order on us. So students that chose Orangina, that's the first part, so that's 10. The word to, oh, that's my fraction line. Number of 7th graders who chose Sprite, Sprite is 40. So there's my ratio. I reduce that down, I can divide by 10, becomes a 1 and a 4. So therefore, that's what the ratio is. The value is if you would divide the top divided by the bottom, but 1 divided by 4 is going to be a decimal. So we're just going to leave that value as a 4th. And then in words, what does that mean? It means that 1/4, oops, 1/4 of the kids, 1/4 of the kids like Orangina as compared to Sprite drinkers. Okay, and the last example says the number of 7th graders who chose Orangina to the total number of 7th graders. So we are asked to compare the 7th graders who like Orangina, so that again is 10, that would be your top number. Compare that to, there's our keyword, there's where our fraction guideline goes, and the total number of 7th graders is 50. So that's our ratio of Orangina to total people. If I wanted to reduce that fraction, that would just divide the top and bottom by 10. It's going to equal 1/5 or 1 to 5. And then it asks the value. The value would be basically 1 divided by 5, which the decimal will be 0.2, or we can just leave it as a fraction, 1/5. And in words, we would say 1/5 of the students like Orangina. One more important thing on this lesson is you're supposed to know is the difference between a part-to-part ratio and a part-to-whole. And you can see here on question 1 where you compare the people who want Sprite to the number of 7th graders who chose Orangina. That would be a part-to-part because you're looking at just two groups of people, Sprite compared to orange. But in number 2, that would be a part-to-whole. And the reason that would be a part-to-whole is because you're talking about the people who chose Sprite to the total number of 7th graders and the total of the group. There's a big difference between part-to-part ratios and part-to-whole. So number 3, it's who chose Orangina compared to those who chose Sprite. So we have two part groups. We have a group that likes Orangina and a group that likes Sprite. They're complete parts. And then number 4 would be a part to whole again, because it's Orangina compared to everyone. And those people that like Orangina is included in that group when they do the total. And one last thing, this is the first page of your packet. Let's make sure that after this lesson you really understand these words well. The first word is a ratio, and a ratio is very simply a comparison. So when I ask you what's a ratio, that's really the only word you have to come up with. It's comparing two numbers. And it's always a multiplying relationship. Typically we write our ratios like fractions. So we'll have our fraction line, and this is a ratio of 1 to 3. So just comparing ones of something to 3 of something else. And then they talked about the base quantity and the compared quantity. I want to talk about the compared quantity first. When you say, I want you to compare girls to boys, well, you're counting the girls first. The order is first. So the compared quantity is always the first number. Or, in other words, another term we're going to have is called the front term. And then the base quantity, that's what you're comparing it to, and that, of course, is the back term. One way to keep these straight, back term starts with a B, so does base. Front is the first number you see, it's in the front, and that's what you're comparing. You're comparing something, 3, like here it says 3 dogs for every 8 cats. The ratio is 3 to 8. And then the last example, we talked about part to part and part to whole. Part to part compares part of a set to part of another set, of the same set. So like boys to girls. So you're comparing the boys to the number of girls. Versus part to whole would be compare the boys to the total number of students. That would be a part to whole relationship. And then finally, then they start talking about what's the value of the ratio value, and a lot of kids don't really know what they're talking about. Really, that's just the value when you divide the front by the back. We don't typically write our ratios like this, do we? So like this is the front, this is the back. Typically we will write it 1/3. That would be taking 1 divided by 3. And if it's a fraction like that, we would just leave it as a fraction. We just say it's 1/3. You could change it to a decimal and say 0.3 repeating. Like this one is the ratio of 3 dogs for every 8 cats. So the ratio is 3 compared to 8. And then they basically, you could say the ratio value is 3/8. Or you could divide that and the ratio value is 0.375. Typically, we're going to keep that as a fraction. All right, you now have enough information that you should be able to complete your homework packet. Have fun!